The Physics Behind Planes by Brian Mack. In this video, we will be talking about what makes a plane fly and an example of a stall. So, how does a plane actually fly? Basically, there are four forces that act on a plane while in the air. The first force that acts on the plane is obviously its weight. This force points downward in our free body diagram. The force that counteracts the weight is called lift. This force plays a big role in the reason behind why planes can fly in the air. Drag goes opposite the way the plane is flying and slows the plane down. Thrust is what makes the plane move forward and must always be greater than the force of drag to make the plane actually go somewhere. Let's talk about lift first, since it's the most interesting of the four forces. Basically, the air above the wing has to travel a greater distance because of the way the wing's design was engineered. This in turn makes the air move quicker. This also creates a lower pressure on top of the wing. The air beneath the wing travels at normal speed and creates a higher pressure. The pressure goes from high to low, so from the bottom to the top in this case, creating lift. The lower pressure caused by the increase in the flow of air is also known as the Bernoulli principle. Aerospace engineers use a few equations to find out how much lift a plane could have. The first of the two equations is L, which stands for lift, equals 1/2 times rho, which is the density of the air, times coefficient of lift, which is based off the angle of attack and tells us about the wing, times the plane's speed squared. As you may have heard, I briefly mentioned the angle of attack when I was talking about the first equation. The angle of attack is the angle between the direction the air is moving relative to the angle the wings make with the air. As you increase the angle of attack, you increase the coefficient of lift, meaning you have more lift. There's a problem though. When you reach a certain angle of attack, as you can see in this graph, the plane falls into something called a stall. A stall is when there is not enough lift to counter the weight of the plane and allow it to fly. This causes the plane to literally start falling out of the sky. A stall occurs when there is not enough air flowing over the wing to create lift. If you look at this cross-cut picture of a plane's wing, you can see air being represented as the white and black lines streaking across the wing. At the tip of the wing, you can see that the air does not connect with each other and the top of the wing has no air going across it at all. This is bad news. This means that there is no air creating a lower pressure above the wing and causes the plane to fall. Another bad thing happens when we make the angle of attack too much. The plane encounters more drag. The second equation is used to find how much drag a plane gets at a certain angle of attack. D for drag equals 1/2 times rho, which is the density of the air, times the coefficient of drag times the velocity squared. As you can see from this graph, you can tell that as you increase the angle of attack, you increase the amount of coefficient of drag you get, meaning more drag for the plane. The next force we will talk about is thrust. Thrust is what makes the plane move forward and must be greater than the force of drag in order to do so. There are two things that most planes have to generate thrust. The first of the two is the propeller. This is usually located at the front of the plane or at the wings. Another thing that generates lift are the engines located at the wings of the plane. These engines pull air into it and push it out the back at high speeds, much like what the propellers do. This causes Newton's third law to come into effect. Newton's third law states that for every action, there is an equal and opposite reaction. This means that the air being pushed backwards by the engines or propeller makes the plane move forward. The next two forces, drag and weight, are pretty much self-explanatory, so we will not be going over them. We are now nearing the conclusion of this video. Now, I will be showing you the video of the aerodynamic stall. Before I go on with showing you this video, I must warn you, this may be disturbing for some viewers. Viewer discretion is advised. Don't worry, the plane wasn't carrying a lot of passengers, 7 to be exact. Here's a video from CNN talking about what happened to cause the plane to crash.
When the cargo jet took off from Afghanistan for Dubai last month, it had 5 armored vehicles on board, each weighing about 13 tons. They were strapped down in a precise way to keep the load balanced. On cargo flights, if straps break and the load shifts, disaster.
Since the cargo shifted the plane's weight towards the back, it caused the plane's nose to tip forward, creating a really big angle of attack and decreasing lift. This led the pilot to try and regain lift by banking towards the right and dipping the plane's nose down. It was too late though. The pilot did not have enough altitude to regain the lost lift and ended up crashing into the ground. And thus concludes this video. I would like to thank you all for watching, and don't forget, physics rules!